This is 3.2 polynomial division. So we're going to be doing long division with polynomials, which uses the same steps as you did in long division back in elementary school. So let's kind of review how we did the long division back in elementary school so we can then apply it to the polynomials. So if we're going to divide 176 by 3, you might recall that you put the number on the outside, 176 goes on the inside. You might have called it a house or something like that in elementary school. And then we see how many times the 3 goes into the 1, which it doesn't, so then 3 into 17. It goes in there 5 times, so we divide first, then we multiply 5 times 3 to get 15. Right down below, then we subtract, and then we bring down the next number. So the steps that we just went through are divide, multiply, subtract, and then bring down. And those are the same steps we're going to use when we're doing polynomials. So then we repeat that process again. How many times does 3 go into 26? 8 times. 8 times 3 is 24. Subtract to get 2, and there's nothing left to bring down. Now, one thing they often don't teach in elementary that you're going to need to know is that if you end up with a remainder, that remainder goes over the number you were dividing by. So we're going to have 58 and 2/3 for our final answer. So divide, multiply, subtract, bring down, and then the remainder to make a fraction. All right, let's try that with a polynomial. All right, so same kind of setup. You're going to have a value on the outside and a value on the inside. And then when you do that first step of divide, you're only going to look at the first term of each. So we only care about the 2x squared and the x. So we're going to see how many times does x go into 2x squared? Or what is 2x squared divided by x? And I think it's easier to stack them in order to see what that is. So if we had 2x squared over x, we can subtract these exponents, see that we can get rid of that x and rid of that x. So we end up with 2x. So 2x is what we put up top. Then we're going to do the next step, multiply. When you do the next step, multiply, you multiply by everything. So 2x times x is 2x squared, and 2x times -3, -6x. Okay, so we divide, we multiply. Now we're going to subtract. Be careful when you subtract, especially with negatives, because subtracting with negatives actually is adding. So -5 plus 6 is an x. So we divided, we multiplied, we subtracted. Now we're going to bring down. We have x minus 3. Then we're going to do that same first term over first term division, x over x. Well, that equals 1. So we'll put plus 1 up at the top. Then we multiply to get x minus 3. Then we subtract, and it's 0. So there's no remainder. So our final answer is 2x plus 1. Okay, let's take a look at another one of those. Zoom in a little bit here on number 2. So we have x cubed minus 4x squared plus x plus 6 divided by x minus 1. Why don't you try setting that up and seeing if you can get started with the division steps, divide, multiply, subtract, bring down, and then come back and check and see if you're moving through those steps correctly. All right, so hopefully you started by taking x cubed divided by x. So that is going to equal an x squared. So that's what we put up top. Then you're going to multiply. We get x cubed minus x squared. Then we subtract. These two equal 0, but -4 minus -x squared, so that's really going to be a plus, is -3x squared. And then bring down an x. And then we do the whole process over again. So how many times does x go into negative 3x squared? Well, negative 3x squared over x. Looks like it's going to be negative 3x. And then we multiply negative 3x times x minus 1. So we get negative 3x squared plus 3x. And then we will subtract. That gives us 0. Be careful when you're subtracting here. Negative 2x. Then we bring down a 6. So plus 6. How many times does x go into negative 2x? Well, that would be negative 2. Then we multiply. Negative 2x plus 2. Then we have to subtract. We get 4. There's nothing left to bring down, and this doesn't divide in, so that must be our remainder. Now when we write the remainder, make sure that you always put a plus sign, which is different than if we were just using an integer with a fraction next to it. So we have plus 4 over x minus 1. And that whole thing is our final answer, but don't forget that plus sign right there. All right, take a look at number 3. Again, please try to set it up, solve it, and then come back and check it out. All right, so you should have x minus 3, 2x cubed, plus 3x, plus 7. Whoops, scoot that up a little bit. All right, we're gonna see how many times x goes into 2x squared. Well, that would be 2x cubed. The answer would be 2x squared. Then we're gonna multiply to get 2x cubed minus 6x squared. And when we go to subtract, you might notice that there's not an x squared term to subtract from. So we can do 2x cubed minus 2x cubed, which would be 0, but we can't take a 3x minus a negative 6x squared. So most of the time what we want to do is put in a 0 x squared term when we're writing it out. But I hadn't told you about that, so you probably hadn't put that in there. So in the future, if you're missing a term, put a 0 placeholder in. So now we're going to do 0 minus 6, minus a negative 6, I'm sorry, to get 6x squared. And then we're going to drop down the 3x. And then when we do it all again. So x goes into 6, x goes into 6x squared, 6x times. Then we'll multiply. And now everything lines up nicely. We're going to subtract. We have a negative, so we're really adding. And then dropping down the 7. One more time. X going into 21x. That goes in there 21 times. Then we multiply. Then we subtract. We have a remainder of 70. So when we put that up with the rest, we're going to say plus 70 divided by x minus 3. Don't forget the plus sign. Can't just stick it on at the end like a normal fraction that we would have with an integer. All right, so that is 3.2 long division. In the next video, I will show you how to do synthetic division.